All right, let's talk about the invisible forces that can threaten even the biggest, most expensive construction projects out there. Today, we're going to deconstruct IS 4967. This is the standard that tells us how to prepare our most critical infrastructure. We're talking massive dams and river valley projects for the unbelievable power of an earthquake.
Look, when you're building something that's meant to last for generations, you're not just working with concrete and steel. No, you're building against the Earth itself. And when the Earth decides to move, Indian Standard 4967 is the playbook, the one guide that makes sure your structure actually stands a chance. It's all about getting the right data so you can make the right calls. And hey, before we dive into the real nitty-gritty, if you're a professional who needs to stay on top of these kinds of critical industry standards, you're going to want to subscribe. We break them down so you can get back to building with confidence.
Okay, let's do this. Here's our game plan. First, we'll cover the why, what this standard is all about. Then, we'll get into the groundwork, all the crucial data you need before you even break ground. After that, we're going inside the dam itself to see what kind of monitoring has to be there. And we'll wrap it all up with a super clear, actionable checklist for your project.
So let's kick it off with Section 1, Understanding the Standard. What is IS 4967 actually trying to do here? At its heart, IS 4967-1968 is about one thing, and one thing only: data. It's basically a framework for collecting seismic information systematically before, during, and long after construction. This isn't about crossing your fingers and hoping for the best. It's about moving from reactive repairs to proactive, data-driven safety.
Which, brings up a really good question. We all get that safety is paramount, but what does this data actually let you do? Why is it so incredibly important? And this is the whole point. This standard forces you to think long-term. It's not about what you do after an earthquake hits. It's about understanding the unique seismic personality of your site for years before you design anything, building the structure accordingly, and then listening to it. You're basically giving the dam a checkup for its entire life to make sure it stays safe. So, if data is the name of the game, where do you even start? Well, that brings us to Section 2, the pre-construction investigation. This is the bedrock of the entire safety plan, and it all starts years, and I mean years, before construction. Now, get a load of this timeline. This is where the standard gets really serious. It says your network of observatories has to be up and running for at least 5 years before you even finalize the design. 5 years! Why so long? Well, because you need to understand the background noise, the small, constant tremors, to build a really accurate picture of how that ground is going to behave in a major quake. That long-term data, it's the single most important ingredient for a safe design. And to get that data, the standard is super specific. This is not a suggestion, it's a requirement. You need a network of 5 observatories. This isn't about just sticking one sensor in the ground. It's about painting a complete seismic picture of the entire region. So this network is set up like a hub-and-spoke system. You've got one main observatory right at the heart of the project, close to the dam site. Then you have 4 subsidiary observatories surrounding it, casting a wide net. That 70-kilometer spacing is key. It ensures you can pinpoint the exact location and size of any seismic event in the area. This table really breaks down the different jobs these observatories have. The main one is the powerhouse, right? It's got the more sensitive, comprehensive gear. And the star player, the real difference maker, you can see it right there, is the 3-component accelerographer. This thing is so important, it's only required at the main site where the most critical data gets collected. So what in the world is an accelerograph? Well, think of it as your project's earthquake black box. It just sits there quietly, but the second the ground starts to move in a big way, it snaps into action and records the raw acceleration, the real forces the earthquake is throwing at your site. Okay, for all the engineers and procurement managers watching, this one's for you. These are the specs you just can't compromise on, straight from the standard. Take the damping, for example. That 60 to 70% is absolutely crucial. It makes sure the instrument is measuring the ground's movement, not its own wiggles. And the battery backup? I mean, that's a no-brainer. This thing has to work when the power goes out, which is exactly when you need it the most. Every single detail here is about one thing: reliability. So, you've spent years gathering data about the ground. Now it's time to build. But the monitoring doesn't stop. Oh no, it actually gets way more personal. And that brings us to Section 3, permanent in-dam instruments. You literally have to build a nervous system right into the structure itself. This leads to probably the most practical question any site manager is going to ask. Okay, so where exactly do these permanent instruments need to go to actually work and, be compliant?
The placement is actually pretty genius. It's all about understanding how the structure moves and flexes. You stick one accelerometer at the base to measure what the earthquake is feeding into the dam. You put another one at the very top to see how the dam reacts or amplifies that shaking. And for really tall dams, we're talking over 100 meters, a third one at the midpoint gives you a complete picture of how the whole structure is bending. It's about capturing the dam's whole story during a quake.
But hey, acceleration is only one piece of the puzzle. To get the full picture, the standard demands more. You've got displacement meters, which tell you how much the dam actually moves. We could be talking centimeters or even meters. Then you have dynamic pressure gauges on the upstream face measuring the insane shifting force of all that water. And finally, structural recorders help model how other critical parts are handling the stress. Altogether, these give you a comprehensive health report during an earthquake.
Okay, that was a lot of technical stuff. So let's just boil it all down into Section 4, your compliance checklist. These are the big takeaways you can plug into your project plan, like right now.
Let's just break it down into 4 must-do actions. 1. Plan way, way ahead. That 5-year data collection period is the best investment you'll ever make. 2. Get the right tools for the job in your observatories. 3. Build the monitoring instruments right into the dam as you go. And 4. Make sure it all works, all the time, especially when everything goes dark. Following these steps isn't just about ticking a box. It's about taking full responsibility for the long-term safety of something that will affect thousands of people.
So as we wrap this up, I'll just leave you with this one thought. The concrete and steel in your project are designed to last for 100 years or more. This standard is the blueprint that makes sure your safety plan can last just as long. So the real question is, are you building a legacy or are you building a liability? And that is our deep dive into IS 4967. If this explainer helped you get a better handle on this critical standard, please do us a favor and like, share, and subscribe to ISO Automation Lab. We'll see you in the next video.